All right, so part two of Java versus Rust. We are going to make an API call today using similar libraries found in Java and Rust and see which runs faster in a sense that you get the response back faster. Now, starting with Java, what I'm going to use in Java today will be pretty straightforward actually. So we are going to use the java.net itself, the closure package that we have within the JDK itself. So I'm using JDK 11, and this is part of the JDK itself. I'm using this because in Rust as well, we are going to use something closer to the library that Java has. So for this one, for Rust, we are going to use request. The name is very catchy, to be honest here, but yeah, we are going to use request, and we will be using the asynchronous API call here in Rust as well. Um, Rust as well. So we're saying we are using Tokyo to make sure that we're running a asynchronous call, and we're saying, hey, run in this main function here. Now, since we are doing asynchronous in Java side of things, I am going to add a completable future to do the same. But yeah, let me go uh, sort of line by line. So we are going to make an API call to this API azfly IO. What this one does is when you provide a name, it gives you some random is based on the names. Okay. Now, first thing first, we are going to create a HTTP client object using HTTP client we already have, and using this new HTTP client. Now, once we create the client, we will also need to create a request that we are going to send, right? So we will use the builder class from HTTP request, which is new builder HTTP request builder class, and we are going to pass this API URL, and it will be a get method called, and we are going to build a request. Pretty straightforward. Once we build the request, we what we will do is we'll start a timer. Just right before we send a asynchronous call, and then after after the response is received, which is then accept here. After the response is received, then only we will like log it. So we will like log the time it took to respond. We're using the instance here, Java the time itself, and most of them, well, everything is Java package. Yeah, there you go, Java dot. Yeah, trying to make sure we have uh, the libraries that we're using that's already there, and yeah, and then we're also making sure that it does not go haywire. So using join at the end. Um, and to make sure it runs in a separate thread outside of main thread, we are going to use completable future and wrapping this HTTP response with completable future. So we're going to send an asynchronous call once we get the response. Then that's why we're using then except that way, wait till we get the response. Same thing that we use in Rust, right? So that would be like await here. So this is the Java side of thing. Um, you know, Pretty straightforward here itself. Now let's go to Rust and see what we are doing here as well. So now for the Rust side of things, we are also going to use now instance outside of the instance sorry script that we use. Um, and we'll also use the milliseconds as our marker. Same thing with the Java side of things. Now, now this elapsed will calculate the differences here in Rust, and then we're logging that response here, and then this OK here is pretty much kind of equivalent to like return in Java. So yeah, so let's go line by line actually. So we are using request library here. So these are the dependencies that we are using request library. We're using this version and Tokyo to wrap that up around the main function that we have. Basically, it's telling that main function to make sure to align with the asynchronous request that we are sending. Alrighty, so and also for exception handling, we are handling it here, and the result, if it's exceptions out or not. And now for the Java side of thing, that's one of the reason we are like making sure it's we are accepting this and also joining it just in case it does not complete and all. But in our demo, we don't need to worry because it's just one user, just me running a single instance and in my local anyway. All right, so now let's go with this one. Now with Rust, right? We don't need to say like string URL and all. Um, Rust is pretty smart. Obviously, Java is also there, but since I'm using version like if I do 35, it will know that it's an integer and all that along those lines, right? So, but just to make it short, um, yeah, we'll just go with this one. This URL, same URL, same name as Bishao. Now we will send a request. It's more like a stream that we use in Java. Like when you are doing a map, you reference the method name, and in this case, it's going to be a function fn. But with similar concept, and we are going to wait until this execution is completed. And then once we get the response back, we are going to respond it in string format or text format. So same thing is being done here. We're saying, hey, once we receive the response, treat it as a string and then send it in a string format. We will see as a JSON when we look at it, but it's like in under the hood, it's a string as a response. So going back to Rust here itself, duration is calculated with elapsed here. Um, and yeah, pretty much, if I were to use SLF4J annotation, and then I could have done out of instead of sys out, similar concept, but this is their default side of things. And then we're saying everything is okay. Let me just double check what I said actually. Oh, yeah, this is like 200 response. But if it fails, what happens? Let's see, it should not fail. Okay, so far so good. We also have everything. These are the dependencies. Yeah, this is like similar to the form file in Java, right? You have dependencies and then you have versions and all. All right, so now I'm using this particular website to log the request. We'll make like 7 calls, and based on the response, we'll fill this in, and then it will show you a nice graph. Okay, so starting with let's do Java first. Okay, let me start Java now and see how long it takes to get the response back. Yeah, one thing to note here, while compiling, the Java takes more time than Rust. That's something I've noticed. All right, so the first one took 844 milliseconds. Let's put this one here. Alrighty, so okay, I thought somebody was at the door. 844. Now let's read on this. Okay, the second one took 681 milliseconds. Let's put this one here. Let's rerun this again. Okay. We have a nice graph coming along. Oh, and I forgot to mention like the response here, right? So it's saying I am 44 years old, and I think this is wrong. It should have said 64. All right, so 679 milliseconds, pretty quick. Okay, 730 milliseconds. And lastly, I'm gonna do seventh run and then have it at odd numbers. Okay, 653. All right, now let's go to Rust. Let's do the same thing. Um, and let's click run. Yeah. Compiling is slightly faster than Java. Okay. So, oh wow. Okay, this is 217 milliseconds uh, um, on the first run. Let's do the second one. Second one should be pretty quick. 233 milliseconds. So far, looking bad on Java side, and Rust is still leading with quite a bit of difference actually. Uh, okay, okay. Yeah, I'm not sure how JDK, like the latest version, like 21, 24, behaves, but this is being done in JDK 11 for the Java side of things. And for Rust, I'll have to check the version. Let me completely run this. Okay, and let's do this guy right here. 208 milli, oops, 208 milliseconds. Alrighty, so 208 milliseconds. All right, as you can see right here, looks like uh, Rust is pretty fast compared to Java that I'm running here on my local. And I said I will check the version. So let's see, something to do 11 something. Sorry, 1 dot something. Yeah, this is the Rust version that I'm using. And for Java, let's go to terminal. Let's do Java version. Yeah, I'm at 11. So yeah, there you have it. Rust is pretty fast compared to the one I'm running on my local. Once again, this is not the benchmark, but this is just a demo of using my local machine. So, um, but anyway, thank you for being here all the way to the end and help me share what I found. Alrighty, thank you.